Okay, number 5. The point 31 is dilated by a scale factor of -1/3. The center of dilation is at the origin. Find the coordinates of the image. Well, it's always easy when the center of dilation is at the origin, because all we have to do is multiply our point of our pre-image by the scale factor. So we just have to do 3 times -1/3, which gives us -1, so that's our x value. And then 1 times -1/3, and that's our y value. So our y value is -1/3. So when it's centered at the origin, that's a lot easier. All we do is just multiply the scale factor. If you'll remember, that coordinate notation is kx, ky. So it's the scale factor times the x and the scale factor times the y. Okay, number 6. This one's a little bit more difficult because it's not at the origin. The center of dilation is not at the origin. So you have point 11.7. It's dilated by a scale factor of 1/2, and the center of dilation is at 3.1. Now there's a couple ways that you can do this. The way that I would recommend is to take your center of dilation and your pre-image point and find the rise in the run. So to get from 1 to 7, you go up 6, and to 3 to 11, you go over 8. So you found your rise and your run. Now we're going to use our scale factor, and so we're going to multiply our scale factor times the rise and times the run. So if we do 1/2 of 8, that gives me 4, and 1/2 of 6, that gives me 3. So I'm going to take these two. This is how much my x is going to change and how much my y is going to change. And I'm going to go back to my original, where my center of dilation was, and I'm going to add 4 to the x and add 3 to the y. So we're going to take our original point, which was 3 and 1, and I'm going to add 4 to this value and 3 to the y value. So and that gives us 7, 4. Okay, so what we did is we took the center of dilation, and then we took the point of our pre-image, and we found the rise and the run. Once you have your rise and your run, then you're going to use your scale factor to figure out how much you're going to rise and run to get to your image point. So we did 1/2 of 8 and got 4, 1/2 of 6 and got 3, and then we add these numbers back to our center of dilation. Now that's one way of doing it. Another way you could do it, and if you had graph paper that would help, is we could graph these. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 5, 6, 7. So 11.7 is about right here. This is our pre-image point. And 3.1 is right here. So if we calculate the rise and the run to get to that point, we go up 6 and over 8. Well, we know that our image point is going to be collinear with the center of dilation and your pre-image. So we know it's going to lie on this line somewhere. So we take 1/2 the rise, so we're going to go up 3. So 1, 2, 3, so now we're right here. And 1/2 the run, so we're going to go over 4. 1, 2, 3, 4. And then that will be our image point. And so that's 1, 2, 3, 4, 5, 6, 7. And then we went up 1, 2, 3, 4. So 7, 4. Now it's the same thing we did here. We found the rise was 6. The run was 8. I took 1/2 the rise, which was 4. the 1/2 the rise, which was 3. 1/2 the run, which was 4. And then I just added it, started back at my center of dilation, and went up 3 and over 4. It gives us the same answer. So it depends on, I guess, how big your points are. If you want to make a graph that big, or if you have graph paper, you can do it that way. But this is, if I don't have graph paper, this is how I would suggest to do it.